Okay, so in this lesson, we're going to review polynomials and conics a little bit, and specifically the things that you really need for calculus. Okay, you need it all, but these are things that you'll do more often than other things. Okay, so if you kind of look at this first thing, factoring, huge deal. Okay, we'll get to that. This first example may seem kind of weird. Okay, sorry, I had to pause there for a second. So with this first problem, this looks like a really strange thing. When you get into calculus, you'll understand why this is not random. This is a very specific concept, and right now we're just going to study the algebra of it. And so remember that if you have something in parentheses, it's replacing what was in the parentheses. So everywhere there's an x, what we're going to do right here is plug in an x plus h. So that means instead of x squared, it's going to be x plus h squared. Instead of 3x, it's going to be x plus h. Notice the parentheses so that I can do order of operations. And then plus 2. There was no x there, so this just stayed plus 2. Okay, minus. Now, since you're going to write more than just one thing after this minus, we need to put a parenthesis again. This is all about making sure we follow the order of operations. And then this whole thing was all over h. Now this is going to seem kind of annoying, but it's going to simplify very nicely in the end. Okay, and like I said, this is a calculus concept you'll learn more about next year. When you have something in parentheses squared, it does not mean you can square the first thing and square the second thing. In fact, it's probably easiest if we just go ahead and write it out something like this, so that you get x times x, that's x squared, x times h, here, and then this x times h, that's going to be 2xh, or you could write it as hx, doesn't matter, and then h times h is h squared. Now you're going to see this problem again, and x plus h squared always turns out to be this, so that's kind of a nice thing. It's really weird in the first go around, but then it works out nicely. So I just distributed that 3, and now I'm going to distribute the negative. Okay, and at this point you're going, what in the heck are we doing? Why are we doing it? The why will come later. What are we doing though? So we're just doing algebra. Okay, now everything over here should cancel with something else in the front. So I like to start at the back. The negative 2 cancels with the positive 2. The negative 3x cancels with positive 3x. Negative x squared, positive x squared. Okay, now look at what you have left. They each have an h. And so I can factor out that h. There's that factor word. That's gonna come up a lot. And if you factor out an h, it will cancel then with the h on the bottom. So what we have left is this 2x plus h plus 3. This has something to do with a calculus concept called the derivative. Again, you'll learn that next year when you take calculus. Okay, so then with this example 2, first of all, this says to solve for a. There's no equal sign though, and this actually happens on your homework a little bit. It's just a typo on our part. There should be an equal 0. Otherwise, the directions would just be to factor. Okay, so this is change the variable to make it easier. So something that we use in calculus sometimes is called a u substitution. So I'm going to use the letter u here, although you could use any letter you wanted. And we're going to let u be this weird thing that shows up more than once. And what this does is it simplifies what you have. It makes it look nicer, it makes it easier to work with. At this point, you need to factor this. So I'm going to go over it on this one. The next time, we're just going to factor. You've got to be able to factor if you're going to take calculus. If you don't know how to factor, you got to get help with that. But just to remind you, with these trinomials, you're going to go 2 times negative 15, and that gives you negative 30. You've got to figure out the factor pair that adds to negative 1. And so if you think about 5 and 6, if one of these is negative, it will multiply to negative 30. And if we want them to add a negative 1, then the bigger number, 6, needs to be negative. So then you can split apart this middle part. So plus 5u minus 6u minus 15 equals 0. If you remember from factoring, you've been doing this since Algebra 1, factor out what you can here, so that would just be a u. We're left with 2u plus 5. Okay, and then we want to factor out what we can here, and remember, you want to have 2u plus 5. Sometimes that means just factoring out a 1. In this case, it means factoring out a negative 3. And so one of your factors is this 2u plus 5. and one of your factors is what you factored out. This is why it's called grouping, factor by grouping. We're gonna actually solve for u here. So if 2u plus 5 equals 0, then u must equal negative 5 halves. You just subtract the 5, divide by the 2, and then u equals 3. Now we're not done because this wanted us to solve for a. So we got to go ahead and substitute back in. This is really a squared minus 3 equals negative 5 halves. And if you want to solve this, you've got to add 3. Now I'm not going to go over the number crunching here. You need to be able to do this without your calculator. So this is 3 minus 5 halves. That's just a half. And then we would square root both sides. And I just want to remind you that when you do that, you should get a plus minus. And that's square root of 1/2. Now the best thing about calculus is once you get a final answer, you rarely have to simplify it. So we're going to leave it like this. And then I'm going to do the same thing over here. I'll work over here so I have a little bit more room. A squared minus 3, that's going to equal 3. And because we're just plugging in a squared minus 3 in for u, so that becomes a squared, add the 3 over, equals 6. And you get a equals plus minus square root of 6. Okay, so we ended up having 4 answers. All right, so then we're doing almost the exact same thing here. Okay, so it might not be so clear as to what you need to let u, but remember that we typically have like a u squared in the front. Okay, and e to the x squared, that's the same exact thing as multiply those two, e to the 2x. So what we're going to let u equal is e to the x. So that's how we get the u squared here. And then we get minus 5u plus 6 equals 0. And then you factor. I'm not going to go over factoring on this one. You're going to need to do that by yourself. One other quick way to factor is always by guessing and checking. Like thinking, what can I put here and here so that if I multiply u times u, I get u squared. This number times this number should be 6. So, I mean, it's either going to be 2 and 3 or 1 and 6. And then the outside and the insides have to make negative 5u. So that ends up being minus 2 and minus 3. If that bothers you, you need to do grouping method, like how we did in red up here. All right, so then u equals 2, u equals 3, and now we substitute back in. E to the x equals 2, and e to the x equals 3. We did this part when we did our log chapter, because if e to the x equals 2, then that means log base e of 2 equals x, or you could say take natural log of each side. And we end up getting these answers. All right, now the only thing, it didn't happen here, but it might happen in your homework, is let's say on another problem, I'm going to switch even to a different color, you got natural log of, say, negative 5. If you got something like this, you need to cross it out. It's not a solution. It's like an extraneous solution. You can think of it that way. Because you can only take natural log of positive numbers. That has to be true, just as a quick reminder. Okay, so let's look at the next page. Find the center of the ellipse. Now, we did this in a different chapter from polynomials, but if you notice, we've already talked about polynomials, we've talked about quadratics, we've talked about logs and e's, and now ellipses. And that's what you're going to do in calculus. You're going to bounce back and forth between all the things you've learned, reviewing along the way, but you can't forget everything, you know, in one day that from the next day, okay? So remember with ellipses, the x's are always first. So we split it out. We made sure we had all the x terms first, and then we got all the y terms second. And then anything else that didn't have an x or a y, like this 48, got subtracted to the other side. Okay, we don't want a number in front of this x squared, so this is perfect. We take that negative 4, and then we do completing the square. We half it, box it, square it. If you just somehow never learned this during conics, today's the day. Add 4. If this equal says the two sides are equal and I put in a plus 4 on the left, then I have to put in a plus 4 on the right. Okay, then we do the same thing here, but we have to factor out that 4. We don't want a number in front of x squared, so by factoring out the 4, there's that factor word again. This is a common theme in this lesson. We got to go 48 divided by 4, and then negative 12 is what we're going to do the whole half it, which is negative 6, box it, square it. So plus 36 completes the square. I really did 4 times 36, okay, which if you're like, I can't do that in my head, well then just times 2 times 2. 36 times 2, 72, times 2 again is 144. If you can't do that without the calculator, then calculus is going to be rough for you. But you can do it, you don't have to do it in your head. You could do it over here on the side. All right, so then we end up getting x minus 2. Where did I get minus 2? From the box. Plus 4. Y minus 6. From the box. And then you got to add this up. I think it's easiest if you kind of go ahead and do the positive numbers. That's 148 minus 48. Think of it like money. That's just going to be 100. And then remember with ellipses, we want this to be 1 over here, so I got to divide everything by that number. So I'm kind of doing more than we actually need to answer this question. To figure out what number goes here, you just got it. It's like 4 divided by 100. Just do 100 divided by 4. That's 25, and that goes in the bottom. So we didn't really need these bottom two numbers to figure out the center, but there may be another problem where that's more important. So remember, that's just opposite the number next to x, opposite the number next to 6. And you should have your blue formula card somewhere in your notebook that you could refer back to if you needed it. Okay, so let's look at this next one. Okay, this is trig. Okay, we reviewed a little bit about exact values, but one thing we could do here is just think of this as like an x. Okay, or you could even do a u substitution on this one if you wanted to. Like you could say, let u be cosine x. So then you have u squared minus 1 equals 0. And you could either factor here or add the 1 over. If you do add the 1 over, that's what I think most people would do. Remember that when you square root both sides, you get a plus minus. Okay, if you square root both sides. All right, so plus minus 1. So what does this mean for our problem? This means that we have cosine x equaling positive 1, and we have cosine x equaling negative 1. You don't have to think too hard about this if you had those exact values memorized that we asked you to memorize. So cosine of what equals 1? Cosine of 0 equals 1. So x equals 0. Okay, so having those 24 memorized from the table before, really going to help you here. Cosine of what equals negative 1? It was pi. Okay, if you were like, I don't have those memorized and I'm never going to memorize them, well, you're going to end up doing a lot more work. But remember, what you could always do is this. You could think about what these numbers are. See, this is already more work than I've done. Remember, cosine is the first number, so you could figure out what is the angle such that I get 1 and negative 1. All right, so those end up being your answers. X equals 0, x equals pi. Now, there are actually infinitely many answers to this. So typically in calculus, they're going to give you a time frame, usually 0 to 2 pi. And so if you were thinking, hey, if we went around the circle, we'd get that same answer. You're right, you would. So that's why I only have to list these two. Okay, number 6. This gets back into polynomials. Is x equals negative 1 a 0? Remember 0, that's the same thing as a root or an x-intercept. That's important. That's going to help you. Making that connection is going to help you remember this. So probably the easiest way to do this problem is to use that remainder theorem thing that says, let's plug in what we think the 0 is, and our result will be the remainder if we would have divided. And so the reason this is easy here is because you can take 1 or negative 1 to any power. And so right now, I'm just plugging in negative 1. So negative 1 to an even power, that's going to be a positive 1. So that becomes just positive 2. Negative 1 to an odd number is going to be negative. So I have also a minus in front. So that makes 2 negatives make a plus. It's not that these two make a plus. You have to go to the power first. Okay, so here you have to take negative 1 to the power. It's an odd or even power, so that's a plus, and a plus and a plus make a plus. Here we have an odd, so that's going to be minus 1. Negative 1 to the 6, that's going to be an even, so that's a plus. 2 times a plus would be a plus. And here, something I like to do is kind of like cross off things you know cancel. So like this plus 1 and that minus 1 cancel. Okay, this 2 plus 1, that's a 3, and that's going to cancel with that minus 3. So in the end, I get just 2. That's the remainder if I would have divided. If you had done synthetic division, which I'm not going to kind of go into a lot of detail here, but your remainder would have been 2. So is the answer yes or no? We want the remainder to be 0. It's not 0, so no. Okay, so we could use this theorem. We could have used synthetic division or even long division. All right, those are also things we have. Okay, example 7 is kind of weird. It's kind of like what we did on the front, but notice that this is a minus, this is a plus. So if we want to use, and the directions here, by the way, should have been simplified. If we want to use u substitution and let u be b squared minus 7 root b, then this does not become a, well, this does become a u squared, and that's just a times there. But it's not minus a u squared, because that's not the exact same thing. So we can actually use a different letter here. We'll just use v. It doesn't matter what letter you use. Use any letter you want besides a and b, since those are already taken in this problem. So here's v squared. So if you think about how could you factor this, okay, both of these have an a. So then we get u squared minus v squared, which from your factoring days all the way back to Algebra 1, this should be ringing a bell here. Difference of squares. Something squared minus something squared. So that's u minus v and u plus v. All right. So this is pretty far as we can go with what we have. So let's do the substitution back in. And if you're thinking, I could have gotten this far without doing the whole u and v thing, well, great. It's not required. It's just a tool that you put in your toolbox to make things easier. And when we're substituting back in, remember, after a minus, if you're writing more than one thing, you need to put some extra parentheses in there. So here we have b squared minus 7 root b, and it's plus v. So you don't need parentheses after plus. Certainly wouldn't hurt, but you don't need them. All right, now if you think about this, some things are going to cancel. So like here, see this minus, it's going to go here and here, and that's going to cause the b squareds to cancel. Over here, we have the 7 root b's canceling. So we still have a way out in front. Let's see what we have left. We have negative 7 root b and another negative 7 root b. That's going to make negative 14 root b. All right. And then over here we have b squared plus b squared. That's 2b squareds. And then let's go ahead and do negative 14 times 2. That's going to make negative 28. And the rule kind of is put these things in alphabetical order. The only exception would be the radicals should come last. And so this is still kind of messy, but it's a lot neater than that. And when we're doing calculus, the better you can simplify things, the easier things are going to be for you. So that's why we do them. Real quick, I want to point out just some things on the homework that just making sure that you need to know. Number 3, probably using synthetic division would be more helpful here than anything else. Just YouTube this, or go back on our chapter 8 when we did this. However you want to do that. Like, use your resources if you needed to, okay? If you look on the next page, see how this says solve for x? There should be an equal 0 there. There has to be an equal sign if it's really a solution. Same thing here, number 7, equals 0. And same thing with number 9. So sorry about that. That might not have tripped you up, but just wanted to make sure.